Hello there. Today I'm doing a demonstration of a mask attack with Hashcat. Now this is pretty interchangeable, almost with a brute force, because mask attacks can do everything that a brute force attack can do. Just brute force can't do everything a mask attack can do. And essentially all a mask attack is a targeted brute force. You can see on the Hashcat documentation on their website. Yep, a mask attack tries all combinations of a given key space, just like a brute force attack, but more specific. And when we mean more specific, when we say more specific, what does that mean? So I'm going to scroll down here a bit. Where'd it go? Here it is. So we are going to be using built-in character sets. So like L, lowercase L, it's all lowercase. You have one for it's all capitals, down the list. So what this does exactly is if you have like 10 a 10 digit password, so like just 10 digits, 10 numbers, would you want to do a brute force where you're trying uppercase and lowercase letters, or would you just want to do just digits? Well, clearly you want to do just digits, because if you're trying upper, lowercase, special characters, everything else on a password that's just a number value, well, you're wasting a significant amount of resources, and something that could take seconds to break that's going to take, potentially years. So that's why this is very useful. Really important to note is how does a mask attack compare to a dictionary attack? Because if you are familiar with Hashcat and you've used platforms like Try Hack Me, Hack the Box, or studying for something like OCP, you are familiar with a dictionary attack. Just to recap, dictionaries are just long word lists containing possible passwords, and Hashcat goes line by line calculating the value and see if it matches whatever hash input you gave it. And if it matches, if the hash values are equal to something in that file, then you know the password. But passwords can have stupid, crazy amounts of possible combinations. Just a 10-digit string has 10 billion different password combinations in it. Whereas if you're looking, like, this is 10,000 words passwords. This is a default one that comes with Kali. This is only 10,000. Your password, if it's a 10-digit number, it's probably not going to be in here. Now, there's bigger, more common, well, probably the most common dictionary file. It's going to be RockU, a random 10-digit number, even though it could take seconds for a graphics card to crack. If you're just using a dictionary attack, you're not going to find it. One more thing that's really important to note and to understand is how much resources are actually needed for some of this stuff. So like I'm going to be keeping a low number of characters for the demonstration, even if I go do a high password complexity. But you can see on this list, this is just a general idea. And they're using a good graphics card for this one too. At a certain point, certain number of characters and complexity, it is just impossible with our current technology to brute force certain passwords. So just keep this in mind. But generally, better graphics card you have, better results you're going to get. And if you want to follow along, I would just like to go to CyberChef, put in MD5 as your operation, just carry it over, and put in a random, make a random password. And you can try to break this hash yourself. Oh, and a common mistake that a lot of people will make, which I made it myself a lot, is when you're making the hash value, you need to consider white space. So like this password kitty, here's the hash value. But if I put a space, completely different hash. Put a new line, completely different hash. So make sure when you're putting this into your hash file that you want to crack, make sure there is no white space when you calculate the hash value, or it's just not going to work. All right, let's get started. These are the three different types of passwords we're going against. First is all numbers 10 digits, so just 10-digit string, then seven long, upper, lower, and numbers, and then 6 uppercase, lowercase, digits, and every special character. So let me open up Hashcat. This is for just digits. So it's hashcat.exe. I'm on Windows, Linux is just hashcat. Then -m0, that is hash mode 0. If you want to know which hash mode to use, just Google hashcat example hashes and it'll tell you. You can see right here, MD5 is 0. Then we have A3, that is attack mode 3. How do I know attack mode 3? Well, you can open, or you can just run hashcat -help. Run that. Scroll up just a little bit, and you can see attack modes are listed right here. Yep, and we're doing brute force, so we want number 3. Then you supply the path to the text file containing your hash. So all numbers 10 digits. And then this is the interesting part. The -1, this is the custom character set, or the name of the mask that we want to use, and what it's comprised of. So I said this password, we're going just against 10 digits. So what type of characters are we going to use? Well, we're just going to use digits. So it's $D. And remember, in the documentation listed earlier, you can see right here, built-in character set D, just numbers. And how many times do we want to call that custom character set? Well, I'm going to do 10 times because I'm assuming that the password could be anywhere in length from 1 to 10. And really important on the end there, --increment. What this does is it'll run through sequentially and it'll try password length of 1. So it'll try 0 through 9. That doesn't work. It'll go 0 through 9, 0 through 9. So it'll go down that list. So even though we're calling this custom character set up to 10 times, if the password was, 6 digits long or 7 digits long, it would still crack it. And on this, if the password is shorter than what we're anticipating or what we're expecting for worst case scenario, Hashcat will stop. It's not going to keep going and waste resources and wear down your GPU and run up your power bill. So, with that said, let me run this. 3, 2, 1, go. And it cracked the password that fast. You can see on the bottom here, it took 5 seconds to crack 10 digits. So let's break down this output. This is the target hash. That is our cracked password. Here you just have some status or session information. Yep, it's cracked. Time it took. This is just time for the 10, for that final guess length of 10. Where is it at here? Yep, you can see in the final it was trying all digits for a length of 10. Oh, and something, if you're curious, when it's glitching out there, each time Hashcat runs through a new guess length, it'll give you a status update before it moves on the next one. You can see this one here, it tried 9-digit long password. And you can see it failed, it exhausted. So it failed, so it moved on to the next one. That is pretty much all, all this is really that simple. You just have to define the character set, how long you wanna, or what length you're anticipating, and you just run it. All right, let's do 7 upper, lower, and number. So you can see here's the command. Pretty similar on the rest of it, just changing the path, still in hash mode 0, attack mode 3, but the different types of characters we're using, that changed. So after the 1, I said upper, lower digits, so you have to put $U, $L, $D. Remember, refer to the documentation if you forget what's what. We can leave this as 10 because, remember, we're incrementing it. So even if the password's 7, it's still going to go up to it and stop. And this wasn't here last time. This is -O. So that just runs, it tweaks Hashcat a little bit so it runs more efficiently. You don't need it, but usually it's a good idea when you're doing more complex stuff. So let me run this. 3, 2, 1, now. There, it's glitching out because it's failing for some of these. Oh, I already got it. Yep, I have a finish before I could even finish my sentence. Yep, here's a password, kitty99. So same status information as before. But you can see that changing our mask work just fine. All right, last one. We're doing 6 characters long, all character sets. By all character sets, I mean uppercase, lowercase, and digits and special characters. So let me clear this out and I'll put the command in. Mode 0, attack mode 3, change the path to the hash file, and then all we need is a question mark A. And that's for all. Again, check the documentation. And we can leave it 10 times as before, leave -O, leave -increment. Remember the question mark A, it's upper, lower, digits, and special characters. So let's run this now. Should be pretty fast on this one because it's only, yep, there it is. All right. Yep. We have C0OLZ exclamation point. So hopefully this video was pretty informative and you learned something. Again, the whole point was just to be an introduction. You can get more advanced and more technical with Mask, but you got to start off from the fundamentals first. And this also should have shown why it's a bad idea to use older hashing algorithms and why it's a bad idea to use weak passwords because someone can break them pretty fast. So keep yourself safe.